So from the Unit 3 progress check, part B is looking at decreasing the volume of the container. Okay, so no, that's B. All right, so I'm a visual kind of person, so I like to visualize what's going on. So in the container, they basically have a kind of like a plunger, you know, for a syringe. So they're compressing the volume of that container. So the volume is actually going to be half of what it was before. And the key part to this question is that they say the temperature isn't changing. So because the temperature is the same, what that means is that one whole side of our favorite equation ever is going to kind of just be equal to x. Okay, so the equation that should hopefully come to mind when we're talking about gases is the combined gas law or ideal gas law, which is PV is equal to nRT. And R is a constant. It's the gas constant. T is your temperature, which is a constant. And N is the number of moles, which they're staying in the container, like they're not leaving or going anywhere. So like this whole side is basically a constant. So the only two variables left, if it's at a standard temperature, is the pressure and the volume are your two go-tos. Like those are the ones that are going to be changing. So we're concerned with pressure, what the pressure is doing if you're changing the volume. Now, looking at this diagram, this helps me kind of visualize that since the volume is getting less, the pressure has to be greater. But we can show it in the equation by solving it for pressure. And you can see that the pressure is equal to nRT over V. And like we said, this whole top part is really constant. So the only variable that's changing is velocity. Volume. The volume is decreasing. So because volume is decreasing, and it's the denominator of this equation, then pressure has to increase, okay? So let's say this is like our volume original. Our pressure would be pressure original. But then our final volume would be equal to nRT over V squared. V over 2, because our velocity, wow, I had physics right before this, can you tell? Our volume is half as much as it was. So that too effectively, mathematically, is going to actually be multiplying by the pressure. So the pressure should be about twice as much. Okay, so our original pressure is going to be 2 times that because our volume is half as much. So, and that's because, again, volume's in our denominator. So, so that's a good mathematical way of looking at that, is that the denominator is less, so the pressure is going to have to be larger in order to equal that.